All right, so the way we're gonna prove this is saying the way to solve this. We need three sums, all right, and we're gonna deduce from these three sums to find the main thing we want, which is going to be 1 plus 2 plus 3 plus 4 all the way down to infinity, and that is going to be equal to negative 1/12 somehow. Okay, so we're gonna figure that out. Okay, we're gonna move back up here. So let's start off with a sum we know, S1. We're gonna call this sum S1, okay? And this sum is gonna be 1 minus 1 plus 1 minus 1 plus 1 minus 1 all the way to keep going, okay? And in a previous video, I proved that this sum right here is equal to 1/2. If you don't know why, then I suggest you watch that previous video. But all right, so we have this sum going on right here, right? And let's go with another sum we know, or not that we know. We're gonna figure out, okay? So we're gonna call this sum S2, and we're gonna go 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7, all the way down, okay? And so we're gonna try to figure out this sum right here, right? Because we know what this sum is equal to, and so we're gonna try to figure out what this is right here. So let's try multiplying this sum right here by 2, okay? So what would happen if we multiplied it by 2? Well, so first and foremost, we'd get 2. We'd get 2s2, right, is equal to, and remember, multiplying something by 2 is just adding it by itself again, okay? So we get 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7, all the way down, okay? And so now we're gonna add this to itself, but we're gonna shift it over by 1, right? We're gonna go 1 minus 2 plus 3 like that, okay? And you may ask, like, how are you allowed to do this, right? Wouldn't that be breaking some rules? Well, think about it. If this is an infinite sum right here, even if we shifted this over, they would still be subtracting each other by the same amount, right? Because these are both infinite. We can shift them however many we want. We're going to go plus 3 minus 4 plus 5 minus 6 all the way down, okay? And so do we get when we do this, okay? So we're gonna put this minus sign right here. So 1 minus nothing is just 1. Negative 2 minus 1 is, oh no, I'm sorry, we're gonna add it to each other. Negative 2 plus 1 is minus 1. 3 minus 2 is plus 1. Negative 4 plus 3 is minus 1. And look at this. Look what we have here, right? We're going to keep going down, all right? So plus 1, minus 1, plus 1. We're going to keep going all the way down. Look what we have here. We have S1, all right? And so look at this. 2S2 is equal to 1 minus 1 plus 1, which is just the same thing as S1 right here. And we know that S1 is equivalent to 1/2, okay? So you have 2S2 is equal to 1/2. And we can, divide both sides by 2. And we have S2 is equal to 1 over 4. So look at this. We have a value for S2, 1 over 4. And we have a value for S1, which is 1 over 2. And look at this. We're getting closer to the sum we actually want to find out, which is right here. Okay? So now let's keep going with this, okay? So if we're going to call this sum right here, we're going to call this one S3, okay? So how do we write that? We're going to go, let me write it right here. S3 is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6, all the way down, okay? And so now, so how do we manipulate these two so that we get this right here? Well, let's take our S3 right here, S3 minus S2, right? And let's see what we get from that. Is equal to 1 plus 2 plus 3 plus 4 plus 5, 6, 7. We're going to keep going down. And we're going to minus, all right, we're going to minus this one right here, right? S2 is 1 minus 2 plus 3 minus 4 all the way. So we're going to go minus 1 plus 2, right? Minus 1 plus 2, minus 3, plus 4, minus 5, plus 6, minus 7, all the way down, all right? Because all we did is distribute this negative sign out to all of these terms right here in this, right? So we're gonna subtract them both. So 1 minus 1 is equal to 0. 2 plus 2 is equal to 4. 3 minus 3 is equal to 0. All right. 4 plus 4 is equal to 8. 5 minus 5 is equal to 0. 6 plus 6 is equal to 12. And look what we're noticing here, right? Look what we notice here. Each of these, although we have zeros in between all of these are all factors of 4, right? And they're going by 4 times 1, 4 times 2, 4 times 3. It's just going to keep going down to 4 times 4, 5, 6, 7, 8. So we can try factoring out a 4 from all of this, can't we? So let's do that. So we're going to, so S3 minus S2 is equal to, all right, we're going to factor out a 4 here. 4, 1 plus 2 plus 3, all the way down. And look, 1 plus 2 plus 3 plus 4 all the way down. Well, that's just our S3 again, all right? So we're going to substitute this for S3 again. So we have 4 S3 is equal to S3. Now let's replace our S2 here for our value that we found, 1/4, all right? So minus 1/4. And so look what we have here. We have S3 minus 1/4 is equal to 4S3, okay? And so now we can just do simple algebra. We can subtract 3, or we can subtract S3 on both sides. So we're going to do that. Now 1/4 is equal to 3S3, right? We just subtracted. Then we're going to divide 3 on both sides of this equation. And we have S3 is equal to negative 112. And we know S3 is equal to this little sum right here, right? 1 plus 2 plus 3 plus 4. And so this is pretty amazing, actually, because it blows my mind how positive integers, 1 plus 2 plus 3 plus 4 plus 5, all the way down to infinity, right? These are all positive integers, how they can add up to this kind of weird sum right here, negative 112. This is a fraction. Not only this is a fraction, this is a negative fraction, all right? And, you know, I thought this was mind-blowing, so I want you to, maybe just, I hope this starts some debate in the chat room, right? Does the sum of all these positive integers, does it really equal to a negative fraction? All right? I want you to discuss that with other people.